Hi guys, I am back with another Fmge question. Hepcidin inhibits option A, absorption of cobalamin, option B, transfer of iron into enterocytes, option C, folic acid synthesis, and option D, respiratory oxidase. So pause and guess the answer. So we have two types of iron, heme iron and the non-heme iron. Heme iron can get directly into the enterocytes via the heme transporter. Okay, and non-heme iron it cannot get into the enterocytes. It needs to it needs to be reduced. So Fe3 plus it gets converted into the Fe2 plus via the duodenal cytochrome B enzyme. Okay. Then this iron Fe2 plus it enters the enterocyte via the DMT1 transporter. Okay. So depending upon the body's need, the iron it can get stored in the form of ferritin. Ferritin is actually the hypoferritin plus the iron. So, and if the body needs the iron, then this Fe2 plus it again goes into the blood via the ferroportin one and portal, and then this Fe2 plus is again converted into the Fe3 plus via the enzyme called as the hepastine. Okay, so this iron Fe3 plus which we call as a ferric iron. Okay, so ferric iron it again gets like attached to the plasma transferrin, and then from the and then with the help of the transferrin and with the help of the transferrin molecule, it gets it gets to the to the bone marrow or liver. Okay. The important note that we should take in this diagram is that the hepcidin is a molecule. It's a hormone which is released by the liver, and it actually inhibits the uptake of iron from the enterocytes. Okay, so actually, what it does it degrades the ferroportin port for the iron. So so that's why the iron it can't get into the blood. Okay, so hepcidin inhibits the iron transfer from the enterocytes. Now that we have the answer to our question, let's review other options. So cobalamin, we call it as vitamin B12. Okay, it can be inhibited by several factors like pernicious anemia. This is an autoimmune condition where the body's immune system attacks the cells in the stomach that produce the intrinsic factor. So intrinsic factor is important for the absorption of the cobalamin vitamin B12 in the small intestine. Without intrinsic factor, cobalamin cannot be effectively absorbed. Okay. Now, GI disorders, certain GI disorders like Crohn's disease, celiac disease, and bacterial overgrowth can impair the absorption of cobalamin. Okay. And medications, some medications like proton pump inhibitor like the omeprazole. Okay. Uh, they are used to treat the acid flux, and H2 receptor antagonist used to reduce stomach acid can interfere with the cobalamin absorption. These medication decrease the production of stomach acid, which is important for the release of cobalamin from the food. Okay. Now folic acid synthesis. So synthesis of the active form of folic acid known as the tetrahydrofolate THF can be inhibited by certain factors like antifolate drugs, methotrexate, which inhibits the dihydrofolate reductase enzyme, thus preventing the conversion of dihydrofolate to THF. Okay. Now, trimethoprim, it's an antibiotic which directly inhibits the enzyme DHFR, thereby decreasing the conversion of dihydrofolate to THF. Okay. Bacterial inhibitors like yeah. So they also inhibit the dihydropteroids in this DHPS. Okay, an enzyme required for the synthesis of KH. So respiratory oxides. So respiratory oxides are a group of enzymes involved in the cellular respiration in the final step of ETC, that is the electron transport chain. The respiratory oxidase enzyme complexes are found in the inner mitochondrial membrane and in the plasma membrane of certain prokaryotes. The most well-known and essentially studied respiratory oxidase is the cytochrome C oxidase, also known as the complex 4. The function of the cytochrome C oxidase is that it catalyzes the transfer of electrons from the cytochrome C to the oxygen. Okay, so thereby reducing the oxygen to water, and in this time this energy is utilized by the ATP synthase enzyme to produce the ATP. Okay, so you can see on the right side of the figure the some drugs that can directly inhibit the respiratory oxidase. So have a look at them. So our answer will be transfer of iron into enterocytes. Okay. So this was a very interesting question, and I love to give explanation to this. Thank you guys.